So we'll discuss about the topic about how to insert a node at a given position in the linked list today. So we'll start with the video today.
Hello friends. Welcome to my new data.
Just a second. Okay. So let's start with the video.
Hello friends. Welcome to insert. Let's insert the node at a position 3. Here, 10 points to position 1, 8 points to position 2, and we need to insert new node to position 3, that is 8 and 11. Here, 10 points at position 3.
So it is not audible.
And insert
1 second.
after that.
Is it audible now?
Below is the algorithm for this. Let's see working of it through a demo. Step 1 creates a new node having data as 15, and next node points to null. Moving further. In order to insert new node at given position, we need to traverse list till position -1 node. For that, we create a temporary list node variable, by name previous, and point it to head. Moving further. In order to keep track of number of nodes traversed, we create a count variable, and initialize it to 1. It is because first node is already traversed by previous node. Moving further. Next step is to execute few steps in a while loop. The while loop executes till previous node traverses to a node, which is just before position node. The condition used is, count should be less than position -1. Currently, value of count is 1, and value of position is 3. Thus, count value is less than value of position -1, that is 2. Thus, statement in while loop executes. In while loop we just traverse previous by 1 node. And finally, as now previous points to second node, thus we increase value of count by 1. Again while condition is checked. This time value of count is 2, and 2 is not less than 2. Therefore while loop condition fails, and loop terminates. This signifies that, previous node has reached where we can now add new node. Moving ahead. We will create a temporary variable by name, current. This variable will hold next node to previous. Our main objective is to add new node between previous and current node. Next step will be to update next pointer of new node, to point to current. Final step is to update next pointer of previous, to point to new node. Thus, we successfully inserted new node at position specified. The final list becomes as 10 at position 1, 8 at position 2, 15, that is our new node at position 3, and 11 at position 4. Let's move to Eclipse and see it's working through code. Usually, interview question would be, given list node head, integer data, and integer position, insert data as a node at the specified position. In singly linked list class, we create a method by name, insert at position. This method takes in head node, integer data, and integer position. And it returns back head node, after inserting node at the specified position. Let's code in method what we demonstrated in the slide. First we perform checks on boundary conditions. We call length method which we created in our previous tutorials. This method returns back length of linked list. We store length in size variable. Then we perform check, whether position is in range of size or not. If position is not in range, we simply print message on console as invalid position, and just return head node. Moving ahead, let's create a new list node, with the integer data provided as argument in the method. Thus, creating an instance of list node, with data passed to constructor, and next pointing to null. Moving further, we make a check that, if position is 1, that is, when we have to insert new node at the beginning, then we perform operation as follows. First, we will update next pointer of new node to point to head, and return back new node, which is our new head of the list. Moving ahead, else, in order to insert new node at position other than first, we perform following steps. We create a temporary variable by name, previous, and make it point to head node. Next step will be to create a count variable with value as 1. This variable will track traversal of previous node. Next, we create a while loop with a condition that it should execute till previous node reaches a node that is previous to position node. The condition to execute while loop iteratively will be loop until count is less than position minus 1. Moving further, next step will be, in order to traverse previous node to its next, we simply assign previous dot next to previous, and increase count variable by 1. Moving ahead, we will create a temporary variable by name, current. This variable will hold next node to previous. Our main objective is to add new node between previous and current node. Next step will be to update next pointer of new node, to point to current. Final step is to update next pointer of previous, to point to new node. Thus, we inserted new node at the specified position. Just return head node. This head node will hold linked list with inserted data at the specified position. Let's test its working. In our previous tutorial, we created a linked list with 4 nodes. Let's use it. We call insert at position method, by passing head node, data as 15, and position as 3 to it. That's it. Let's run this Java program. You can see, on first line it prints 10, 8, 1, 11 as nodes of linked list. On second line it prints the same list, but having 15 inserted at position 3. Let's run it with position 1. This time it prints the same list, but having 15 inserted at position 1. Thus, in this tutorial, we saw insertion of node at a given position. So friends,
the easiest part of this program, if I would like to say, is that this program actually serves both the occasions. That is, if you have to insert any node at the beginning, or you have to insert any node in the any other position other than the first positions. Okay, except the very last position. But also you can use this particular code with certain amount of changes. That is, always remember that the last node, in the last node, the memory address always point towards the null. That is, it does not link with any other node. So that we have to keep in mind. So basically, as from the entire structure, if you can see that this coding structure has been designed in such a way so that you can not only insert the elements at the beginning but also in the middle. Now if I just take you to this particular structure out here, as you can see, the sequence of the if I explain you in details a little bit, okay, that is least new node is equal to new node least node 15. That is, they have created this new node. Always remember, the collection of the nodes in the memory is known as memory heap. Okay, so from the memory heap, what happened, one particular node has been considered with its two segments, that is the data segments and the memory address segments. Okay, so once you insert the value, that is 15 out here, that is data segment has occupied one part of the node, but the other part is actually still null. It's empty because this particular node has not been interlinked with any other else. Okay, now what happened, now if you have to insert this particular node in the middle, try to understand, if you have to insert this particular node in the middle, apart from the first position and the last position, that is in the middle at any position, then it is also necessary that you consider the left node as well as the right node. What is left node, right node? That is the two nodes in between which the new node will be inserted. Okay, now the problem comes is that since they are already interlinked, it is necessary that you break the chain, and breaking the chain doesn't mean that you are shifting the value into some particular node. Mind you, the entire thing is completely depending upon the memory address and the pointers or the linkers. Okay, it has nothing to do with the value. All the values will remain intact in their individual position in their respective nodes. Okay, the value does not shift into some other nodes. Now to break this change, it is necessary, as you can see, that it is only the pointer part in each and every node which is getting interlinked with the other node. So to break the change between the second node and the third node, which is presently, this is third node right now, to break this chain between the second node and the third node, it is necessary that this particular memory address must link with this, and this particular memory address, that is the null part which is showing right now, need to get linked with this. So how this part will be, how this will be executed, that means if you say that new node dot next is equal to the current, that means this one, that means this is the new node dot next represents the memory address. Then with the help of that particular code, the memory address is getting connected with this particular node. That is, if I show you in a little, okay, okay, so this is new node and this is the current node. So how will you link this particular node with this node? That means you have to change the pointers. How will you change the pointers? That is, new node dot next is equal to current. This is the current node, this is the new node. So if you write new node dot next equal to current, that means this particular node is actually is pointing towards the current node, that is the node where 11 has been stored. Okay, and how this will be connected with this? That means the previous dot next is equal to the new node. that is out here. As you can see, previous dot next is equal to new node. That means this particular node is now pointing towards this node. So if I take this picture little bit forward, as you can see that now, that means previous dot next is connecting to the new node, and new node dot next is connecting with the current node. So that is how you are what inserting a new node in between 8 and the 11, and that is how the sequence changes. But mind you, again and again I will repeat my same set of the instruction, that the position of the values in their respective nodes doesn't get changed, it doesn't get shifted from one node to the other. So this is the advantage of your, the position of the node changes but not the value inside the node changes. Okay, so this is how you can insert the nodes at any position, and this is the following algorithm that you have to keep in mind. Okay, this set of the algorithm can also be used to perform. Now suppose if I ask you to print, okay, if I ask you right now, let us consider that this particular node, that is the node 15, has been inserted between 8 and 11. Now if I ask you to print all the nodes which is holding the even numbers, that means what? Right from the very beginning of the node you need to traverse. Okay, you have to keep on traversing each and every node, and in whichever node you see that, suppose every time what happened, every node is considered to be the present node. So if I mark it as a present node, okay, then this is the present node right now, like least node previous. Okay, least node previous is equal to head. So initially when you start traversing, that means this node has been considered as a previous node. Listen to me very carefully. Okay, this particular node has been considered as a previous node. Now previous dot data, try to understand, previous dot data, if I indicate, that means it represents the value which is stored into the, so previous dot data modulus 2 is equal to 0. If this condition satisfied, then this is understood that the value which is present inside that individual node, okay, is having the even number, and if it is a even number, then successfully you can print. So these kind of the application you have to uh, learn how to execute, or how to write the algorithm or the code. That is self-built linked list is already provided to you. What you have to do is that you have to identify certain applications which you can do it by yourself also. That is whether, number one, uh, find out all the datas which are present, find out all the even numbers which are present in the linked list. Okay, so if you have to find out the even numbers in the linked list, please ensure that this traversing need to be done. You cannot directly shift from the one node to the other or the second node to the third simply by jumping. Okay, so this traversing process is always required, as you can see, and also a counter variable is required just to ensure that every time you complete the traversion of each and every node, it keeps on counting that so and so node has been traversed successfully. So as you can see that to find out the even number, that is every node has to be considered. Okay, so previous dot data, previous dot data, data represent what's the value which is stored in the individual node. You will divide it by 2. If it is not an even number, then you will simply move on. But if it is an even number, it will print and then it will move on. Okay, so this is basically the logic, like finding out the even numbers of the nodes which are present in a linked list. You can also perform certain applications like summation of all the values present in the node. Okay, suppose a set of the linked list is given. So these all questions are already there in your ISC syllabus. This type of questions have already come in your ISC papers. If you can go through it, then you will see that this kind of small basic applications you have to learn with related to the singly linked list. Okay, you don't have doubly linked list in your syllabus, or neither the circular linked list. So using the singly linked list, you have to keep on performing each small task. That is number one. You can please note it down in your diary or a copy. The first kind of the application that you can practice is find out the even numbers which is present in the, find out the even number present in the node which is present in the linked list. Okay, the second thing that you can perform is that you can also perform find the sum of the datas present in the linked list. Okay, that means you're already, the linked list has been created, you have to perform the addition operation. Okay, you have to sum up all the operation. Yes.
So I'm not understanding the loop part.
Okay, that is while
While
count
part.
less than equal to position minus 1. Okay, now the thing is that uh, out here, as you can see, the position is 3. When it is position equal to 3, it is given that that means that on the third position, okay, presently in the third position, which node is there? 11 is there. Okay, the node which is containing the data value 11. Okay, this is presently the node position. Okay, that is present at number 3. Now what you have to do is that if you have to insert 15 in the middle, the node which is containing the data value 15 in the middle, that means this will become third and this will become fourth. Okay, now if you remember, as I always said, that if it is an array, every array has a specific size. So if you have to increase or decrease the, if you have to like insert any new value into the array, then the first and the foremost thing that you have to do is that it is necessary that you increase the size of the array, and then you can store the value. So without changing or varying the size of the array, neither you can add any value, neither you can shift any value. But linked list is based on the memory address. It is a random memory address, not specified allocated memory address. That you have to understand. So thus, if you insert any node or if you delete any node, the total number of the linked list is actually getting changed. Okay, but for that, linked list does not have any specific size. So if you insert any node in the middle also, what happened? The thing is that obviously the total the sum up linked list is getting changed, but it is variable, so there is no specific size. The element is all about the size. There is no specific size related to the linked list, that yes, this linked list will be only of 4 nodes or that linked list only of 6 nodes. A linked list can be of any number of nodes. Why? It is because of the variable it is because of the dynamic memory allocation. Why dynamic memory allocation? That is, you can only create a node when you have the data. If you don't have any data, you cannot create a simple node. Okay, and once that node is empty, that means the node is present in the memory heap, not in the linked list. Try to understand that. Okay, so now considering all these points in the mind, right now this is the present linked list that I am having. Now if I have to insert a node in the middle, suddenly what happened? My third position node becomes 15 and fourth position node becomes the 11. This is what will be my ultimate outcome. So what is that? Once if you try to insert the 15 out here, you can only insert 15 in the middle provided you have visited the previous 2 node. This is the first node, this is the second node. Okay, so that is what it is doing, that it is asked that if I have to insert the node at the third position. Now if I have to insert the node in the third position, okay, the first thing that I have to do is that while count less than position minus 1, forget about position minus 1 right now. Right now, at present, initially I have declared count is equal to 1, which means that my present node is being visited. That is why my count value is 1. Okay. After that, after I visited the first node, I have to move to the second node. Now, if I have to move to the second node, then obviously my counter value will change from 1 to 2 with the help of count plus plus. Okay. Now, once the count plus plus it is moved, okay, again, now the counter value is 2. Now the condition says is that counter less than position minus 1. The position value is 3. So 3 minus 1, what is that? 3 minus 1 is actually the value 2. So 2 is not less than 2. The condition fails. That means right now my pointer is present in this condition in this particular second node. Okay. The loop, the compiler is not moving forward. It got stuck here. Now once it got stuck here, that means from this set, from this particular set, what it is doing, that the pointer value, that is previous dot next, is pointing towards the new node. Out here, as you can see, previous dot next is pointing towards the new node from this particular position. That means what? After this is second node, the position of this particular node becomes third. Right now, previously the chain was straight. Right now the chain, the arrow, the direction of the arrow has changed towards the new node. That means previous dot next is equal to new node. That represent that second node is actually identifying the new node, not the current node, not the current node. Now, how to identify the current node? Current node has to be there, otherwise the entire linked list will be spoiled. So to identify the current node, how will you identify? You will identify the current node with the help of the new node. Understood? With the help of this new node, you can identify the current node. How to understand? That is new node dot next. New node dot next is heading towards the current node. So here it is new node next is equal to current node. So that is how what happened. Right now, the final observation, it becomes that your direction of the linked list is somewhat like this: 1, 2, then becomes 3, and then it becomes 4. Okay, so automatically the size of the linked list increases. I repeat, automatically the size of the linked list increases. Now, if it was like, suppose you have some other node out here. So basically you have 4 node, okay, and you are asked to insert this particular node in between the third node and the fourth node. Then the fourth node has to become the 5th position. So that means your position value will change. That is, you will write position is equal to 4. That means my 15th node will come after 11, after the node where 11 is stored. That is, on this null position will come my this particular node. Okay, and after that followed by another node. So that is how the things are getting changing. That is, the size of the linked list is completely variable depending upon whenever you have the value. When you have the value, only then you can change the position. You can store a data, and you can, with the help of the next function, you can interlink each and every node with respect to the memory address. The data are not getting connected. Mind you, don't involve the data in the middle, because the data has nothing to deal with which data is present in what node. It is completely the next function which is acting like a pointer or a linker between the multiple nodes by the virtue of memory address. So this is the basically how you insert the node at a specific position. Any doubt, Yash?
No, sir.
Okay. So we'll move to the next link. Okay. There we will see how the node can be attached at the end position, and then also we will discuss about the deletion, how to delete a particular node from the linked list. Okay. So I'll move towards the next link.